Hello, welcome back. This will be the part 2 of object-oriented programming using Python. Let's do a quick review of our last video. We covered what is object-oriented programming, how we can create our own objects or user-defined types. We know that a class is a blueprint for creating objects. Objects are instances of a class. This line right here, where we create an object, is called instantiation. Therefore, objects are instances of a class. Each object of a class has its own properties. An example for the exercise 1, it has the property name, the property sets, the properties reps. Properties are also called members. But an object also has some behaviors. These are the functions that appear within the class. Any function that appears within a class is called a method. But these two functions, init and string, aren't just any function. They are dunder methods, double underscore methods. So with that out of the way, let's continue. We know that we have the init method, which is a function that will run every time we create an object of type exercise. The dunder string method will run whenever we call print exercise object. But we also need to represent our object in a way that does not rely on being called by print. Let me show you what I mean. Let's open up the terminal and just create a Python shell. And let me from intro 0 import exercise. Now you may be wondering why it is that after I imported exercise I had output, but we'll get to that in a second. Let me show you something. Let me create some object. Let's call it exercise, and it is assigned to the values overhead press for 2 sets and 4 reps. Great. Let me just call exercise. Notice that we again get that weird output which says that we have some exercise object at some location in memory. How can we fix this? Well, we have 2 fixes to make. First, we need to correct this output that should not be here. Let's exit the Python shell. And let's do this. Let us remove all our print statements and move it to the bottom. This is the first thing we will do. Then we will say if under_underscore name is equal to under_underscore main, and we will just indent these 3. There we go. This will ensure that when we import from this file, we do not get any uncalled output. The next thing we need to do is we need to define another dunder method, which is a function within a class. A function within a class is also called a method. We'll define another dunder method called repr, which will take in as parameter self as always, where self refers to the current calling object. And all we will do is we will copy our string method and paste it into our repr. Now when we go back to the terminal and I create a Python shell and I import the exercise class, the first thing that happens is we get no of this output that we did not call. And when I do this, when I have some exercise object and I call that object, I get an output. OHP 2 sets 4 reps. Great. Now, let's say we had some I wanted you to print the name of the exercise only. Well, you would go print exercise 1. How would you get the name? This is where we get used to something called dot access operator, which is simply a full stop, which now lets you access members, which are variables within our class, and methods, which are functions within our class. We want to access the name. We'll do the same thing to exercise 2 and exercise 3. Save our file and run it. There we go. We got the output squat, deadlift, and bench press. So let us create a different means to access. I'm actually going to remove all these comments because I don't really need them right now. Okay, great. I want you to create a function that returns the name of an exercise object. So write a function that returns the name of an exercise object. I'll give you like a minute. Just a regular function. It appears that I did not charge my laptop. Oversight on my part. Okay, so you probably did something along the lines define, and you had some name, let's say get name, which takes in as parameter some exercise object. You gave it some name, exercise, and all you did was say return exercise dot name. Let's try this. Let's do print get name, and we'll pass in exercise object. Let's pass in exercise object exercise 1. Okay. And let's do the same thing 2 more times. Get name, pass in exercise object 2, and one final time we'll print get name exercise object 3. These 3 function calls should output the values squat, deadlift, and bench press. And there we go, squat, deadlift, bench press. It works. But here's an issue. What if for some reason I don't pass an exercise object? I say I pass something like a string and I just say exercise. And now I try running my function. There we go. You already see above here that I get some error. A big old error. Let's stop. And what that error is an attribute error. The string does not have any attribute called name. So how can I find a way to ensure that the only thing passed to this function getName is an exercise object? We can add a restriction such as the following. We use a colon, and then we say that the only parameter that exercise can be is of type exercise. So now when I pass in something such as, let's go with exercise, and I try running my function again, string object has no attribute name. Again, well, that didn't work. Well, is there something else that we could do? Let's figure it out. There is something that we could do. Instead of writing this function outside of our class definition, we write this function within our class definition. And remember, any function that appears within a class is called a method. It will follow the basics of any other function with a define keyword, the name of a function, getName, and what is the first parameter to any function that appears within a class? Self, where self refers to the current calling object. So all we will do is say return self.name, which means that when I call this with exercise 1, let me get rid of these. When I call this with exercise 1, what happens is the value of self will get interchanged with the value of exercise 1. So it will essentially be define get name exercise 1 return exercise1.name. And when I call it with exercise 2, instead of it being self, it changes to exercise 2 and I return exercise2.name. That is how the function works. So if I save it, how do I now call it? Well, all I do is use my exercise object. Again, I use the .access operator, and I just call the function name, getName. And I do not need to pass any parameter because Python knows inherently that the value of self refers to the current calling object. So if we do that, and I should wrap it into a print statement so I get output. And I save my file, and if I run it, I get the value of squat. Let me clear out my output. Clear. Let me run it. There we go. We get the value squat returned, which is great. We can replicate this behavior with exercise 2. And if we run it, we get deadlift. So we know that it's working. So now, again, the variables that appear within our class are called members. The functions that appear within our class are called members. And right now we have two types of members. Dunder methods, which are called double underscore methods, and we just have regular functions which are just called methods. These variables, name, sets, and reps, are created for any exercise object that we will ever create. And they will always be set to the parameters that we pass within the function here. So we say name gets set to the value of name from above, sets gets set to the value of sets from above, reps gets set to the value reps from above. To further illustrate this fact, let's create some exercise object, exercise 4, and all I'm going to say is equal to exercise. That's it. I'm not going to pass in name, sets, or reps. And let's run the function. Well, let's run this file. We get an error. We see that our init method missing the required arguments, name, sets, and reps. And this is happening because every time we create an exercise object, we know that the exercise object will be assigned a name, it will be assigned a sets, and it will be assigned a reps. But the thing is, within our function, we do not pass in name, sets, or reps here. There is nothing here. So how do we overcome that issue? We can pass defaults. Assuming we don't pass anything, then we will have default set. And now if we do it, and I'll also print exercise 4.getName, and if I run the function, there we go. You may not see it, but we did get output. It's just that the output is a blank string. So cool. Let us repeat the fashion, and instead of just having a getName function, I want you to create a getSets function and a getReps function. So all we're going to do is you're going to copy this. We will paste it one time and we will paste it the third time. And we'll change it from getName to getSets and getReps. Now this naming convention of saying define get something is called a get method or getters. And the only purpose of a get method is to return some attribute, which is also called a member of the class object. So the only purpose of getters are to return a single attribute of an object. We see that we have getName, getSets, get reps, where get name will return name, sets will return sets, and get reps will return reps. You can go ahead and test those functions out. We can also create setters. Setters are to set the value of a single attribute. Again, following a similar convention, we will say define. Instead of get name, we will say set name, which must take the parameter of the calling object, which is self, and it must also take another parameter that we will use to set the name. In this case, I'll just say n. And all I will do is say that self.name is set to n. That's all I will do. If you want, you can return none, but because Python does it inherently, we will not do that. So I want you to create the sets function and the set reps function. All right. Following that same fashion, you'll say define set sets, which takes parameters self and some other value, let's say s. And the only thing we'll say is self.sets is equal to s. We will define another one, set reps, which takes in self, which is a current calling object, and some way for us to manipulate the attribute. So we'll pass in r, and we'll say self.reps is equal to r. Let's go ahead and test these functions. We notice that our exercise1.name is squat. If I do exercise1.setName and I pass in some string value, let's say pause squat, hopefully the name is changed to pause squat. Last for exercise2.say set sets. We notice there are 2 sets. I will say to 5 sets. For exercise 3, let's do set reps and change it from 8 reps to 12. I will now use print exercise1.getName, print exercise2.getSets, print exercise2.getReps, and hopefully we see the change of pause squat 5 and 12. We got pause squat, our sets didn't change, nor did our reps. Oh, it's because I called the wrong thing. Exercise 3, there we go. My mistake. And there we have it. Exercise 2.set sets. It would appear that for exercise 2.getSets, pause squat is right, 12 is also right, but the set should be set to 5 for exercise 2. Self.sets is set to the value s. Right, self.reps is r, self.name is n, self.sets is set to n. Let me get rid of that for now, get rid of that for now. Exercise 2.sets, set sets. Oh, that's why. It's because I was a sign in it. Set sets, and we'll say to the value of 5. And now when I call exercise 2.getSets, I get the value of 5. Little syntax issues, if you will. So now we see that getters are meant to return a single attribute of an object, and setters are to be used to set the value of a single attribute. Now, I want to show you something called encapsulation. I will just get rid of this. Encapsulation, let me create some encapsulation. This concept involves bundling data, which are attributes, which are also called variables, which are also called members, attributes, and the methods, which is a function within a class that operate on the data into a single unit called a class. This helps to hide the internal implementation of a class from the outside world. Now, the moment you create some class, you have used the principle of encapsulation. So far, you learned what are classes and objects. You have learned what are members, what are methods. We went over dunder methods. We went over regular methods. We also learned how we can use getters to set the value, getters to return the value, and setters to set the value. We will now save this, and we will write one more function. Let us, let me think. All right. In the next video, we will cover inheritance. So that is all for now.